All right. MTG in the house. You check my Bold Fun shirt on? You're rocking the Bold Fun
Nice.
shirt, man.
Hey,
Yeah, man.
Jones.
What's up?
I said, hey, Jones.
Hey. This has been quite an event so far. We're entered the second week now, and this workshop in particular, we've been doing some planning on it, some last minute bug fixes and whatnot. But I am super impressed and excited to show everyone what you've been cooking up. For you to show everyone what you've been cooking up.
Mhm. Yep.
Without further ado, I think we should just get into it. Maybe I do like a little bit of housekeeping first for some folks. Uh, Wrong one. Yes, we're at the AI for All hackathon, where we're combining AI plus Bitcoin because the intersection of those two technologies are just bangers right there. The event is presented by Fedi and Stackwork. Um, Check those guys out, of course, in collaboration with Replit, the number one platform there for coding in the web. And there's a big community around AI. AI right now, they have GPU cycles that you can like purchase and tip people in cycles, kind of like what we do with our flame emojis here or Zaps. We're also sponsored by Hivemind, Spirit of Satoshi, Prem, and Zebedee. So big shout out to those guys. And yeah, without further ado, let's just hop into it. I'm way too excited for this for this workshop.
Yeah.
So
Okay.
MTG, let's let's introduce it. How you want to do it?
Okay. So first, um, okay, can you share my screen? Also, there is no presentation. Uh, so first, before going into this session, I'll just like go over a very quick recap of what we did in the last session. For like, this is the second part of a pay for a Lightning for a OpenAI API through Lightning. So we did a first session previously where we like we created a chatbot where you can write something a prompt, then hit enter, and it will like the request will go to the OpenAI API, create a response, and go back. However, requests to OpenAI is not free, so like someone will need to provide you with a key. But if you don't want to use like if you don't want to open a paid account, you don't want to like connect your card, whatever, and you prefer to just like for example maybe one time or two time usage, so lightning payment is better. So yeah, in the first version we just created a simple chatbot where for each prompt you type and hit enter, we generate an invoice and ask you to pay this invoice. If you pay it, we like let your request go through the OpenAI API and return the response back. Uh, Although this works to some extent, but like as we saw, it can become a bit tedious as like a user experience because like you will see this pop up asking you to pay after each time you write something, and this is not a great UX. So here is this session for a better approach that provides better UX using the L402 specs. Uh,
Well, MTG, I wanna highlight something. Like, if the wallet doesn't have allowances in it, then I think at that point it becomes annoying, right?
yes,
If it does have an allowances, then you can just pay for the subsequent, like for every request. But
yes.
the problem here is that with these AI models, you don't know, like when you're interacting with these chatbots and stuff like that, you can't determine what is the final output, right? You
Mhm.
can, unless you put some restrictions on it and says only give responses up to this length, right? Then you know how. But even if you say up to this length, it doesn't necessarily predict the amount of tokens as well that it's
Mhm.
going to be using.
Yeah,
So you
good
pay.
that you brought this point up because, like, we will later see a problem that we will face that is exactly as you mentioned, and we'll see, like, we will discuss several approaches or how we might tackle this problem related to this non-deterministic output of AI models.
Yeah, my bad for that. And just one more other point. That is the same issue with well, an issue or feature bug, whatever, with Lightning payments, because you don't know until the payment is actually routed what the fee is going to finally be as well.
Yeah.
Yeah. But go on. Sorry for interrupting.
Okay, so where were we? Yeah, so that's what we are going to build this time. Let's just go over the application very quickly. We will not live code it or go very deep into the code because it's a little bit convoluted, and as John's mentioned, like it was very last, like I literally wrote it yesterday and today, so it's still messy. But we'll go over the important parts, the parts related to the L402 and the Lightning things. So the application this time, here you find the chatbot window. If you write a prompt, for example, hello bot, and hit enter, it will first try to see if you already have a L402 payment token, something that proves that you have paid, or like you can make requests. In our case, no. So it will ask you, like instead of just showing an invoice and asking you to pay it, to let this only this prompt go through, it will ask you to buy some kind of package. So this way it can allow you to make multiple requests instead of a single request. So we show a simple model asking the user to choose which kind of package you want to go through. For example, the small package is one. It will allow him to make requests that like do not exceed 1,000 tokens. So if he make a first request that is only 100 token, then he will have 900 tokens left. He can make more requests. He make another request with, for example, and it consumes 200 tokens, then he will have 700 tokens left. And like this. So it shows here a couple of packages with different amount of tokens, different prices. Let's go with the medium one, for example. It will generate an invoice for this specific package. Ask the user to pay it with WebLN or mobile. We will pay it. Pay now. Okay. So now, as you can see here, it showed us first that we have a token with 5,000 tokens left. And after it generated the response, it decreased the amount we have by the number of tokens that these two messages consumed. And yeah, now if we write something else, how are you? Enter. It will immediately, without making any payments, without showing anything, with a single request, it will make it to the backend, see that we already have a payment token, and it will generate the new response, decrease the amount of tokens we have, and show it to us. One of the very cool things with this approach is that this payment token you have, you can actually, like, it's to a certain extent stateless. It's not exclusive to this device, so you can actually just export it. This is copy. I copied it. So this is what is the token look like. So if we go, for example, to a new incognito tab, and then open the same website. Here we don't have a token yet. Instead of buying a package, we can just import this token, copy, paste it here. Now you see we have the same, like we can use the same token that user had bought, and it shows the same amount that like the remaining amount that user had. So yeah, like this way, if you use a token and maybe you don't like you used it, but you only used 1,000 tokens out of the 5,000, and you don't need them anymore. So instead of just like wasting this money, you can just give it to someone else that still needs to use it. Okay, so I think that's the all the feature of the app basically. Let's now take a look how this works technically, how the flow of this work behind the scenes. Not in the code first, but like as the steps of the process. So when we first start, we are here, the user write a prompt. The first thing we need to do is to search for a payment token that the client might have. By the way, I think there has already been a like a previous session about L402, so I'll not I'll try not to go in details about that the specs, just uh, some general stuff. Um, after the user write a prompt, we first try to look if the client has a payment token stored locally, maybe in local storage, maybe in IndexedDB, whatever. If we find this token, we need to first make sure it's valid, like because the user might have a token, but maybe the token expired if it has a time limit, or maybe it doesn't have any remaining like credits. If like you saw we did it like each token, for example, in our case had a 5,000 tokens, so maybe it's now 0 tokens. So if it's still valid, if we have a token and it's still valid, we send a request to the API that we have with this token included. If it like even in this case, it might fail with a 402 response status code. Maybe because we thought the token is valid, but it's actually invalid. Uh, but for example, the client code may not have not updated its state. So we will remove the old payment token and try to create a new one. So in both of these cases, that either we did not find a token, or we found a token but it was not valid, or we found a token and we thought it was valid but it turned out not to be. We need to create to get or acquire a new payment token. The way we do that is we show a simple model that asks the user to select a package in our case. Maybe in your application you don't have multiple packages, maybe you only have a single package, so you can like jump immediately to the invoice step. But if you have multiple packages or multiple offers, you show the user this model. After the user selects a certain package, you will ask the API to create an invoice for this specific package. And the amount of the invoice, of course, will be relevant to the selected package. The API now will return two things. It will return a token, which in L402, it's usually a macron, like basically a token signed using a secret key that only the API has. And inside this macaron, you can store multiple things. One of them is, for example, the payment hash of the invoice that you created, maybe the expiration time, etc. But like this token really can be any kind of token that can be signed by the server and validated by the server. It does not have to be a macaron. And actually, in our case, we are using JWT tokens because they are relatively simpler to deal with. So yeah, any token that the server can assign. And in addition to this token, we also send an invoice back to the client. After the client receives this token and invoice, it will show you the user a model asking him to pay this invoice. After the user pay this invoice, we will now have a token, an invoice that we already paid, and a pre-image. So the payment token is actually the token that the server returned at this step. Add to that the pre-image of this invoice that the user just paid now. This is what the payment token is. After we get this payment token, we just store it in the client and try to make this API requests again. But this time we include this payment token. The API this time will see that we have a payment token. It will validate it. By validated, we mean that it will make sure that it was created by the API itself, signed by the API key, and that the pre-image is correct, which is something like very simple, just like you hash the pre-image and compare it with the invoice hash. If everything looks good, it will, instead of returning 402, it will return to us the response of whatever we are requesting. So yeah, that's basically the whole flow of the interaction between the client and the server. If we want to take a very quick look at the code, so it's the same like project that we worked on the last time. So like most of the components and functionalities are the same, but I just like most of the changes are now in the like in the chat context and in the payment context because the flow is different now. But it's like I think the client code is a little bit complicated, so I'm not sure if I should go over it right now. And as I mentioned earlier, it will need a bit of cleaning to be easy to explain. But I think one of the things that we could look into is the actual endpoint for the API. This time we are using only one endpoint. Like in the previous session, we used two endpoints. One get invoice to acquire the invoice for each prompt, and then after that we like hit the chat endpoint. But this time we actually only need one endpoint, but I just did not delete this one. So if we take a look at the chat endpoint, and by the way, most of the code for this API function, like it was provided by Pumi from Albi, so credits go to him for that. I just added the stuff that is like specific to this application, but the 402 logic and stuff was provided by him. So yeah, basically what we do here is we receive a request. First, we pick the authentication header from the request. Like there might be a header or there might not be a header. So if we find a header, the header will have a shape because like this should follow the L402 spec. The shape is usually LSAT. Then the token, whatever it is, then colon, and after that the pre-image of the invoice that we paid. So here we are extracting the token and the pre-image from the auth header. Then we are verifying, like we are checking if this token is valid and the pre-image is valid. What we are doing here basically is just verifying using Jose is a library that provides some JWT functionalities. So we are like giving the token and the secret that we used to sign this token, or we assume that was used to sign this token. If everything is okay, it will continue. If something is wrong, it will throw an error. After that, we check if there is a expiration date and it's exceeded, so we also return false. After that, we make sure that the pre-image is valid and it's the same, like it's the pre-image that is also used for inside this token. After that, finally, because, and this is something that we will like expand further on later in this session, we make sure that the token still has remaining credits. It's not empty because this is not a single use token. You can use this token multiple times. So, but each time you use it, the credits it has, like, they will decrease. So we want to make sure that it still has enough credits. If everything is okay, we return true. So here is payment valid will be true. Now, if it's not true, like if the token is invalid, or maybe we do not have a token at all, then what we will do is we will first check to see if the user is requesting to buy a specific package. By, like, he can just provide us with the package ID, or maybe if he did not provide us, we can just put a default one. If you do not have packages, you don't need this step. You can immediately jump to the next step, which is generating an invoice with some amount. Now, in our case, the amount is related to the package. But as I said, if you don't have any packages, the amount will be some fixed amount or something. So yeah, we generate an invoice. We can put a comment, whatever. Then we need to generate this token. Generate token is a simple helper function that takes an invoice and it will include it in the JWT token. It will use our env.jwt secret variable, and it will set an expiration time of 30 days, and it will return us this token. After that, we need to store this token in the database, and we need to store how much credits it has currently. Because as we saw earlier, when the user is making like request later, we need to decrease the amount the amount of credits that this user this token has left. So we need when we store it in the database, we need to specify what is the initial amount of credits that this token has. After that, we need to return this token on a www authenticate header, and it should have this format: lsat space macaroon. If we are using macaroons, and yeah, it should be macaroon, but whatever, because we are using JWT, it's JWT. And after that, comma invoice, and we put the invoice. Is it very important to follow this, like this shape and like this exact shape? If you like, if the API will only be used by your own client application, then it's not really necessary. However, if you expect the API to be used, or if you want your API to be usable by other clients who do not necessarily need to know how your API should work, or how your specific API shape will work, then yeah, you should follow these specs, because these are the L402 specs. Finally, we return a response with the status code of 402. We include the invoice, we include the payment hash, verification URL, so that the client can like detect when the user pay the invoice actually, and the macaroon in case the user wants to use it however it wants. Okay, so this code will run in the case that the user made the request without a payment token, or with a payment token that does not have enough credits or is invalid. However, if the payment token is valid and it has enough credits, it will just do the same thing that it, like we saw in the last session. It will create like it will call the OpenAI API, specify the model that we want to use, put the messages array, and make the request to the OpenAI API. When it returns to us the response, the first thing we need to do is, like after it returns the response, we need to decrease the remaining credits in this token, right? Okay, so by how much do we want to decrease the credits? Because our packages are based on the number of tokens used, so we want to see how much tokens did this request consume. And luckily for us, we do not need to make this calculation ourselves. When OpenAI create chat completion function is called, the response will contain a data.usage field, and one of the fields here in the usage is total tokens, which is the total amount of tokens that this request used as input tokens and output tokens. So you can just look at that. So yeah, we decrease the credits in this token by this amount. And finally, we just return to the user a response was 200, and we put the content of the response, and maybe we return also the remaining credits in this token, because so that, as you saw, uh, here, after each request, this amount will decrease. So, but the user cannot know just from the token how much credits he has left. So the API needs to tell him that. And yeah, if anything error goes wrong, we just return 500. And that's basically it. All we need for the API is just this single API function. We don't need any other APIs. Now I have two other API. As I said, get invoice is only from the previous session, but we don't actually need it. Token value is just a single, it's a simple API that you can give it a token, and it will look in the database to see if it's valid, and if it has remaining credits, it will return these remaining credits for you, just in case you want to know how much credits this token have left without making an actual request that will consume some tokens.
Hey, MTG,
Yes.
there was a quick question there. I guess you've gone through documentation about like aperture. I don't know if you look at the stuff in Core Lightning and how L402s are being done there. But the question was, let me pull it up. LND, someone's JHU445 is asking if LND could return JWTs instead of macaroons, and it's not in the docs. So maybe you could talk about that decision there, and yeah, where's this JWT coming from, and how does it work in correlation to like in relation to these macaroons or runes, as it's been implemented in other places.
Okay. So first, I'm not sure if LND actually can return JWT. However, the type of token, whether it's JWT, macaroon, or maybe something else, it will only matter on the API side. So if you are the one creating the API, it doesn't really matter what type of token you choose to use, just as long as it's something that you are able to verify that you are the one who created this token, and you can include something that will tell you which invoice this token was created for, then that's okay. The client will not do anything with this token. Actually, it will not try to like sign it or whatever. It will just include it in the further requests with the pre-image. The one
So,
handling the token is only the API.
so then another question would be, I saw that you put what you call it, an expiry of 30 days. And well, your Bitcoin doesn't expire. So, this is a question in designing your packages and your tokens and stuff like that. In my personal opinion, it should be something that takes like a very long time to expire until the end of the service is online,
Well,
ideally.
honestly, I think it should maybe it should not have an expiration time at all, because
Yes,
you paid for this and you should get. But I just left this here so that I can show you, because maybe you don't want to do it as a credits amount, but instead on time based. So just left it
sure.
to show it. But if you are using amount, yeah, you probably don't want to put an expiration time at all.
Yeah, and we also spoke about when you're selling access to APIs. I think what we boiled it down was like three types of access that you might want to provide. One is pay per request. The other one is pay for a period of time, right? And then the other one is this package or bundle kind of mechanism, which like there might be specific details in the design of each one of those, like how you might want to implement it, even the time, etc., etc. But I think like the large categories fall into those. We're trying to show off here the bundle aspect because we feel that because of this indeterministic um, uh, input and output from the API, we feel like from this third-party API especially, it can end up jacking up your personal cost and end up charging you too much on your credit card. Or it could definitely be an attack vector as well. If you're charging sats up front, and stuff. But anyway, yeah, I'm sure you're gonna go through that a little bit more. I just wanted to drive that in as a little sidebar.
Yep. Okay, so I think that's yeah, that should be everything for the API part. Uh, One other thing that like is worth a discussion is the question of whether we can make this token stateless. Can we, like, for example, not use not connect to the database or make the API only uh, like return responses based on the token itself without making a request to the database or something like that? So the answer for that is if you can make the token stateless, then yeah, by all means, go for it. It's like it will be better because more performant. It will be like just having to check the token itself and not doing anything else is better. However, for like it depends on the use case. So, for example, in our use case, where each request will like is supposed to decrease some amount, then you will likely need some kind of state to keep track of what amount you have left. Like if their token was just time based, or maybe it was a one time usage, or maybe it was like you buy the token and you can keep hitting the API for however long you want, then we don't need really a state. Like anything can be stored inside the token. But in the case where we want to have some amount and decrease this amount with each request, then it's not that possible to do that with a stateless token. Why? Because, for example, imagine that we are like maybe some the way that thought about it at first was like this. If I store in the token the amount that this token should have, for example, in the token payload or in the macaron payload, whatever, I put a variable saying credits equal to 100. Okay. And the user make a request. He consumes 50 token, for example. Maybe I create a new token, or if I am using a macaron, I like put a new caveat saying that okay, now instead of 200 tokens, I have 150 tokens, right? And I return this token to the user. Nothing will prevent the user from using his old token that says he has 200 tokens, right? Uh, Nothing will tell me that this token like is invalid right now and there are new token that should be like any the thing that I'm saying right now are all stateful things. Storing which token is invalid now or which token is an old token, or storing how much amount, this is stateful stuff. So like I don't know, I will not say for 100% sure that it's not possible, but like if someone has any ideas for this, then yeah, please share them with us. But I could not come up with a way to make this stateless. But yeah, I think that's okay for this case. Um, One of the other thing that I want to talk about uh, to cover is one of the point that Jones mentioned at the beginning of this session. Uh, yes.
No, I'm
Is
listening.
there a
I
question?
heard my name, so I
Ah.
came up.
Yeah. Uh, so the point that Jones mentioned was the the AI response is non-deterministic. So, as you saw here in this chat API, we are not actually like decreasing the amount that the user used before the request. Why? Because we do not know, like before making the actual request to the OpenAI API, we do not know how many tokens this request will use. We know how many tokens the input has, right? We have the prompt, we have the history of messages, but we don't know whether the response that will get generated will be short or maybe it will be too long, right? And this will change the amount that we need to decrease or that will need to be charged, right? So one interesting case that I thought of, which is one of the, like you can consider it one of the vulnerability of creating such an API, is what if the user, for example, has a token that has 50 tokens left, 50 credit tokens left, and he makes a request with an input of 40 tokens, but the output came out to be, for example, 1000 token. Like he specifically said in his input, create a very very long response, as long response as you can, right? So this request will actually end up consuming, for example, 1500 tokens, although the user only had 15 tokens, 15 credit tokens left, but he made us consume 1500. So, and this will end up like making us go into the negative, right? Because we are consuming tokens on the API side, but we are not getting paid for these tokens. They are just going on the negative side. So how can we deal with this kind of thing? Uh, like there are several possible approaches. Maybe some are better than the other. Uh, a simple thing that I came up with is to just when we are creating the price of the token, when we are when we are generating an invoice for a certain package, I add to the price of the package a small here. When I want to get the price of the package, I put the amount of tokens that this package will have, plus I add a safety margin, which is an amount of token that even if the user goes above the amount that he is supposed to use, it will still be like he will still have paid for that, right? So, for example, if he paid for 1000 tokens, I put like and he has 15 tokens left. He used his request and he has 15 tokens left. I want to make sure that if he make one final request with that will use the maximum amount of tokens. What is the maximum amount of tokens? For example, in our case, with the model GPT 3.5, the maximum amount of tokens that a single request can use is 4000 tokens. So I will make sure that if the final request will use this maximum amount, the user will already have paid for that. So whenever I generate the invoice, I will make sure that okay, I calculate the amount, whatever it is, the number of tokens, plus some profit, plus some fees, whatever, plus a safety margin, which will be if the final request was very long. Maybe one more other like simpler option, but maybe it's not very good, to like if you see that the user has like not too many tokens left, you just prevent him from making the request. But this will like maybe the user can actually make request and it will still remain within his credits token. So yeah, I feel this approach might be better, and there might be other like better approaches for this. So yeah, it's up to you.
Yeah, I think one of the things here that we maybe can you show this modal again, perhaps, with the packages? So this safety
Model
margin,
packages.
I believe, it's also represented in other things in the Bitcoin space. So, for example, we have in applications like Breeze, for instance, there is like a 600 SAT minimum balance that you need to have in the channel. This is similar for like I think most in most cases you have to have on Lightning you have to oh, here's Boomy, he'll be able to give some more context. Perfect. Similar for like Boomy, could you remove the screen? Okay, there we go. Hey there, Boomy.
Hey.
Been for long?
Sorry, how's it going?
Have you tested it out?
Yeah, checking it out. I think my stream was a minute delayed.
No worries, no worries. What do you think? What did you think so far of these packages using L402 and protecting people's credit cards that are, that are offering all these API tools? We want them to monetize their APIs with Lightning, but I think this is an important thing that's not being discussed as much.
Yeah. Exactly, as you say, it's an important topic that has not been discussed that much. So it's great that you bring that up and try to and propose a solution there, how it goes, because I think every application forward will have such kind of questions. So, and especially in that regard, that you don't know how many tokens in your case you have to charge, because that's kind of depending on what the user is requesting, right? So, and how will we model that in a Bitcoin world?
Yeah, for sure. I think you would be also happy to know that we still are using pre-images in the token as well. This is one of my favorite parts of this. MTG, can you please do the export import of the token, please? I mean,
that's nice. That's nice. Yeah.
The export import of the token.
Yeah. So just load it into this one there. So MTG now, he bought tokens on another device, and maybe he's on his mobile phone. He doesn't want to purchase a pack of tokens again, or he wants to give it to his mom because they share Netflix accounts, and now they want to share ChatGPT, funny rhythmic ChatGPT interfaces.
So yeah, clicking on export will just copy it to the clipboard, and then if I go to another browser, import and paste it.
So the export import is the token plus the pre-image, right? So that's basically the LSAT header that you're sharing there.
Yep, exactly. Yeah.
I think that's a great combination. So you have like the default LSAT headers supported, so anybody can build a client also for the API. And any HTTP client that supports LSAT can actually directly work with that. And you have the combination with the packages, because you need state on the server anyway, basically to deduct a certain amount from this like authorization from this user, basically, right?
Exactly. Yeah. MTG always on the bleeding edge of stuff, from non-custodial Nostr, from custodial Nostr to now L402 packages. But yeah, fantastic. There was a question that was coming up that you were getting at, MTG, that before Boomy came up here. I forgot it now. Do you remember? You were showing something in the code there.
The last thing we were talking about was the minimum amount, like the possible ways to secure the API of misuse.
Yes. Okay, so what we've done, we've protected the service provider, right? We've now protected the service provider, so now they're not paying upfront for a user's request response to OpenAI. Maybe they're making some profit on top of it, et cetera, and they're providing this LSAT authorization token to the user where they can use. But what has happened is that there's a couple things. So for that last request, you're having the safety margin, right? And that's similar to how it works in LND, where you sorry, not LND, just Lightning in general, where some amount of funds are reserved that are unspendable by the node. Is that correct, Boomy? Could you talk a bit about that? Because MTG kind of like proposed a solution kind of similar, where 5,000 tokens are bought every time you buy a package, but it's hidden from the user.
Yeah, it sounds similar, that you keep some reserve as a safety margin, right? So if I understand that correctly, because there ultimately it is that you have like a break between like the user sends a request, this is what you charge, and it's not really atomic, right? That you do the request to OpenAI and the OpenAI charges you. So there is it's not a really atomic payment. So you have to make sure that you get enough from the user that you not go into the negative, basically from the data that you buy from the API provider.
Yeah. Could you explain why that reserve is kept on LND, just to make that connection there, or Lightning in general?
So how I see it, for example, in the Lightning payment, you also don't know the routing fees up front. So you only know how much you paid after the payment has been completed. Are you still here? I don't see you anymore. Okay, sorry. Sorry, I was confused there. So yeah, you don't know the exact fee amounts before you do the payments. You only know that afterwards. So you kind of set a maximum amount or certain fee limits for the payment. So if you integrate Lightning now into your application, or if you have something, let's say you have an accounting system, then you only know how much fees you have to deduct from that account after the payment has been succeeded. So that's why you need to keep some reserve, that this account might not go into the negative. So you keep the typical, like, let's say, if I set a maximum fee limit of 1% that I'm paying for this payment, so I make sure that the account at least has 1% more than they want to send to not go into the negative. So, and that's how I see it, very similar, right? So you want to do an API call, so you need to have a little bit more because you exactly only know what you have to pay to the API provider once you receive the response from the API provider.
Is there a case where, and MTG, I don't know if you have any more items to talk about, or if we just do the freestyle here? No? Okay.
No.
Yeah. So do you know why OpenAI would have used this kind of pricing model as opposed to just pay for like some time, computation time, or something? But I guess even with the computation time, you wouldn't be able to predict it as well, right? Like, why do you use this token-based thing? Boomy, that's for you, Boomy.
You were breaking up for me. I'm sorry, but if
Yeah,
Oh,
me
sorry.
too. I thought it's from my internet.
Oh, sorry.
yeah, that's why
No, I was saying that uh, why do you think OpenAI are using this token-based pricing model?
MTG, I think you're better to answer that, but from my understanding is like it's hard for them to calculate. You have the same problem, right? You don't know what the computing resources are required to answer the question that you're sending it to. And it depends on like the amount of the response also, not only like the amount of input that you're giving, but also the amount of outcome that it gives. So you have to have a kind of intermediary to measure that. Does it make sense? Is that correct?
Yep, it's exactly as Bumi said, because like the computational costs of running the LLM models depend like directly on the amount of tokens that are inputted and are generated, and yeah, like maybe in like the first few requests, like as we saw in the previous session, because the model cannot keep state itself. If you are creating a conversation, like each new message, you need to input the whole conversation. So like you can start maybe with 20, 30, 50 tokens, but maybe like you end up with 2000 tokens after a little while. So yeah, it's a very big difference in pricing.
So I was trying to figure out if like you would use something like Prem and you were running your own hardware. Actually, not hardware. You're running your own infrastructure for like AI model and stuff like this. You're controlling your API. You could set up whatever pricing model that you want. Would you eventually result in something similar to OpenAI? Let's say if you use a cloud provider for your GPUs, would you would you always end up with something like this this token based thing because you've never been able to predict it for the user?
Like I guess if I could run my own LLM, like you making it, for example, a more normal pricing as a monthly subscription or something like that could definitely work. However, I think the tokens based is more beneficial for the user because it's likely it will be cheaper than other, like unless the user is heavily using the ChatGPT or like whatever the API it is, then pricing based on the tokens is cheaper on him.
Well, I
Like for
mean, we saw.
example, while I was testing this and working with it in the past week, like so far, I think the billing has been only $0.02. So, and like I was constantly testing, etc. But yeah.
Would you like me to tweet out the link and be careful? Yeah, the reason I ask is because I think this, like, if we're talking about, using L402 as a specification and with AI and stuff like that, I think we also have to like really deep dive into like these business models, the determinism or indeterministic nature of being able to predict what the request and the response pricing would be, how much computation that's going to take, and how much you should charge for it. I think the pay for what you use model is something in which like most infrastructure companies are kind of like going for now. We're moving away from subscriptions. We have been moving away from subscriptions because, for example, Amazon with their serverless and lambdas and stuff like that, they just know instead of clogging up a whole set of resources, allocating some resources for a specific client as a subscription, they could sell a bunch of them, especially their unused resources via serverless because they're spinning up and down and whatnot. Of course, there's issues with performance in some of these things, but I do think it's kind of like the way in which business models are kind of like moving towards this pay-per-use thing, or value for value, in a more kind of like quick transactional way.
Mm-hmm. And Lightning payments is like probably one of the best way to use this pay-as-you-go models. Like, do I really need to connect my credit card just because I used $0.03 on OpenAI this month? Yeah, paying the bunch of sats is much more easier and makes more sense.
Yeah. Boomy?
Yeah, I think what I'm excited about in this regard is always, these things have not been possible before. We're just making these things possible, and it will be interesting to see what we can build around that if we now suddenly have the possibility to charge $0.03 for this one request that a random user is currently doing that on a website. So it's a great opportunity also for like the developers to build things and monetize their apps. So yeah.
Mm-hmm. And it's not hard. Like we just saw how easy it is to put the L402 logic in front of an API. So yeah, much easier than using an actual payment solution.
You mean funny money payment solution? But this is an actual payment solution with hard money here.
I mean, I'm very excited for it. I mean, like all these AI bots that have L402 and APIs that have L402. Maybe someone creates a directory at this hackathon, and then since they're all using the same standard of payment, it'll be easy to just like create some kind of unified API, some uniform client application that's able to interact with them and consume them, even a marketplace or something like this. So that could be pretty cool. Or even like an accounting system on top of it, right? You could see like all the different APIs that you've purchased credentials from, and how much you have remaining or whatnot. That could be some cool stuff. I'm very excited how so much into the APIs we are now, because then it allows application developers to like do things kind of quickly. The Lightning backend that we're using is a get Alby Lightning address, I believe.
Yeah.
Right? So, there we
how
go.
you see like what the open protocols make possible, right? Ultimately it's an LNOL. You just somehow need to get an invoice from somewhere, and that's about it. So, and what I like about the Lightning address solution here is it's really like that there is zero complexity that you add to the existing application. The only thing that you need to do is to be able to do an HTTP request. So yes, you have some latency, but most of the time this is probably no problem. And the advantage is also that you don't have to have any sensitive data within the application, because ultimately it's just a Lightning address that you need to give the app.
Before we close off here, Boomy, one of the discussions we had like in the past couple of days is about like the complexity of building an accounting system and the race conditions and stuff like this. So we maybe have not thought about like all those edge cases. So maybe you can highlight for us, for some of the listeners, if you were to implement this kind of like package and token accounting system that we've done here, what are some of the things that you should kind of watch out for, especially as you guys have built some pretty robust accounting system within Alby, the Alby custodial wallet itself?
I mean, yeah, accounting systems on scale is always tricky, especially if people have an incentive to game it. But having said that, the most important thing when you build the application is that you need to get traction, because you can spend a lot of time on the accounting system, which is not your business logic. which is not doing anything productive in the beginning, but you first need to get adoption that people will actually use it. So I wouldn't spend too much thoughts on that in the beginning, to be honest, for such an API case. But I think one of the main and easiest, like the main problems and the easiest one to understand is the one that you just described. What happens if a user sends 2 requests at the same time? So you need potentially some kind of locking mechanism that a user cannot send 2 requests at the same time, like literally at the same time, because otherwise you would have this race condition. You would have the first request checks the balance, all is fine. Second request comes in, it checks the balance, does the same thing, all is fine. But then the first request executes, balance is deducted from the first request. But remember, the second request already had checked the balance. Even so, if it would come sequentially, it could not fulfill it because the balance is no longer there. But because the balance check already happened before the first request finished, the second request also executes and the account goes into the negative. So I think often that's not a problem depending on your use case, but that's just if you want to have a real robust accounting system. These are the things that you would need to account for. So, and then it's not enough to have a balance field entry where you deduct the amounts from, because you could deduct it twice or something like that. You could not account for these parallel requests, or you would need to have some way to lock the user and to prevent that and things like that. But maybe you want that there could be parallel requests because APIs are there for being consumed, so you don't want to block this artificially. But as I said, I wouldn't spend too much thoughts on that. I would rather spend more thoughts on the monitoring part. The important thing is that you have to notice that. You have to notice what goes in, like what are the requests that come in, and to have if you buy APIs, then like, for example, the Open API one, that you also know your expenses. How many requests do you do there actually, that you can have a feel what's going on there. So if somebody is abusing something, that you get noticed, and then you can harden it. Ultimately, it's always, like any software needs to be always improved and always be hardened the more you scale.
Thanks so much for that. And yeah, you're definitely right. You need to get to that point, but I think it's very important for us to tell some of those listeners about these things, just given your knowledge and experience in the space, and also to be honest, for us selfishly as well, right? So appreciate that. Quick question: would a solution to be implementing a queuing system for those requests?
I mean, I think there are many solutions. Yes, you would need, that's kind of a queue. You just need to have something global, right? That needs to know from each other. Typically, requests like an HTTP request is stateless. The one HTTP request doesn't know anything about the other HTTP request. And with a queuing system, you would have some kind of a global database, a global queue where you say, okay, first I do that, and only when that finished, I do the next one. So ultimately, every web server has such a queue, more or less. But yes, you could implement that. Even though I would say, don't do it. Implementing that is a lot of work, and implementing it is a lot of work. So I would try to avoid that as much as possible. So.
Well,
because like focus on the USP of the application, and second, focus on hardening it. Then, in that regard, always take that with a grain of salt. It always depends on what you do. But if you have the best queuing system and no users, the best queuing system won't help you. So then you could have just not built it. So first build what is useful for the users. Users should come, and then you can build the queuing system to make it harder, because with a lot of users there come potentially more malicious actors.
You heard it here first, folks. in true Silicon Valley mogul fashion, go after users. I'm kidding. It,
Oh, the
it
nice
just
thing is we have money in here. Each user is paying, so go after users. They bring money to your application.
That is very true. That is very true. And like what is also interesting here is that there's a layer in like you have this baseline cost now, right? Well, we always had this baseline cost of like server costs and all this kind of stuff, but it's tied so deeply into the use of the products now. Like if it's a chatbot or whatever, it's like every interaction is paid. So like the more you get people to use this thing, the more you're kind of like, oh, okay, I see money going out, so at least I have to like either, but now I could predict what loss I'm making for every user, but I could also predict the growth and add whatever kind of profit on top of it. It's kind of like transaction fees again in Bitcoin, right? Or at least with Lightning. So there's so many like little parallels here because it's each message or whatever is another transaction. You have this indeterministic thing. There's a lot of parallels there. So when you guys are designing your chatbot interfaces with L402, if you want to recreate some of the bundles that MTG has shown here, maybe you could learn some of these design patterns from things that are happening in Bitcoin or from your knowledge about Bitcoin. Try to draw the parallels there. Of course, share any new findings or comments and stuff like that on Bold Fun. We'd be happy to continue developing out this demo. It's going to be on Replit. It's open source in GitHub. You can spin it up yourself, adjust it. We have some workshops happening tomorrow. I think you have one, right, Bumi?
We do a session. Yeah, we also do a session tomorrow. One thing that I find quite interesting is a bit the idea of bringing value for value payments to applications and in this case, to NPM packages. So imagine I'm building an application, but I'm building on top of your library or on top of your Replit template. And whenever I make money because a user is using my application, I can send a split payment to you who provided the library or the Replit template. So, and a lot of the apps that we currently see, they still have like one-to-one payment flows. But imagine we have like this one-to-many payment flow. So, the chat message, the user is paying for processing the chat message. With that, you buy an API. Your application buys an API, pays an API through potentially even L402 again, but it also sends a split to all the library developers. You take a cut and so on. It could also imagine you paying something like a Lambda function for executing this function itself, also with Lightning. So I think these things are quite exciting and quite powerful what we can model there now. So this is completely impossible in the fiat world, because there it's always like you have to, like a credit card, and you have like this payment acquirer and a payment processor that does something. You get the money then like months later and so on. And here we can, like on request basis, on a cent level basis, we can orchestrate these flows exactly how the application is built actually.
Yeah, this is going to be very interesting, especially with these things like Auto GPT, Super AGI, etc., where you have these different agents and stuff talking to one another, calling out to various APIs and stuff like that. I could see someone creating a service that does like some long-running function for you, but it's like this generic service, and anyone could use it, and it's made for like these bots to talk to. So like it could be like generating a PDF, for example, right? That's a use case that I personally have. If anyone wants to create an endpoint for generating PDF and put L402, link me up. Maybe I put a bounty up for that. We have a secret project we're working on as well.
Yeah, it's a nice microservice, and even you before that you might not have been able to monetize it. Now you're able to monetize it. It's probably quite easy for a developer that's currently listening or they're hanging out in the Discord server to build a PDF generation API. So, but what's the incentive except of making Johns happy, which is a great incentive, but it would also be a nice incentive to make a few sats along the way, right? So, and this is not possible.
Yeah, and we test it on mainnet and Bitcoin. So there you go.
Of course.
All right. Thank you so much, Boomy. Thank you so much, MTG. MTG, do you want to say where people can find you? You as well, Boomy?
Yeah, on Discord, primarily on Discord. And the code, by the way, for the project is on GitHub and on Replit. I'll send it to John, and John will post it probably in the video description.
All right, on Discord there, and Boomy, what about you? Where shall we find you?
I'm also hanging out on the Discord, on the World of Fun Discords for sure. But then you find me everywhere in the webs, mainly on Boomy.
At Boomy, and find MTG.
Boomy@getib.com. So yeah.
Yeah, exactly. We're getting our NIP files set up soon as well. All right, guys, take care. Thank you so much.
Thanks for the session. Super cool.
Thank you.
Bye-bye.